Hi, welcome to Wrapped Reality Explained by Haider. I'm Haider, and on this channel I break down the coolest physics theories in a simple and exciting way. Together, we'll explore the mind-bending world of physics, from space-time and black holes to quantum mysteries and beyond. Before we dive in, don't forget to like, subscribe, and hit the bell icon so you never miss a single mind-blowing episode. Before we understand space-time, we need to talk about dimensions, because space-time is made of 4 dimensions. Let's break them down. 0th dimension. This is just a point. It has no length, width, or height. It only shows a position. Think of it like a tiny dot. No size, just location. 1st dimension. Add length. Now, we get a line connecting 2 points. This is a one-dimensional object. Example, a straight wire or a line on paper. It only moves forward or backward. 2nd dimension. Add width, and we get a flat shape, like a square or triangle. These can move left, right, and up, down, but have no thickness. Think of a drawing on paper. It's flat. 3rd dimension. Add height. Now we enter the world we live in. Objects have length, width, and height, like a cube, ball, or your own body. We can move in all directions, up, down, left, right, and forward, backward. 4th dimension. This is where it gets interesting. The 4th dimension is time. We don't just exist in space, we move through time. Every moment, you're moving in the time direction, 1 second at a time. Together, the 3D world and time create space-time. Now that you understand dimensions, let's explore how space-time really works. In school, we learn space and time as 2 separate things. Space is the where, and time is the when. But Einstein changed that. He said space and time are not separate. They are one thing, space-time. Think of space-time as a huge invisible fabric that stretches across the entire universe. Everything, planets, stars, even you, exist on this fabric. This idea is central to Einstein's general theory of relativity. Quick pause. If you're enjoying this breakdown, make sure to like, subscribe, and tap the bell icon so you keep learning more epic concepts like this. Here's where it gets interesting. Space-time isn't stiff. It bends and curves depending on what's sitting on it. Imagine a trampoline. Place a heavy bowling ball in the center. The trampoline sinks under it. Now roll a marble nearby. It curves around the heavy ball instead of going straight. That's how gravity works. The Earth curves space-time, and the Moon simply follows the curve. It's not being pulled by an invisible force. It's just moving along the bend in space-time. This leads to one of Einstein's most powerful ideas. Mass tells space-time how to curve. Curved space-time tells objects how to move. So, gravity isn't really a force, like Newton thought. It's the result of curved space-time. Even light, which has no mass, bends, because it follows the curves in space-time. In 1919, this theory was confirmed. During a solar eclipse, scientists saw starlight bend around the sun, just like Einstein predicted. This is called gravitational lensing. The sun acts like a magnifying glass, bending light as it passes by. This discovery shocked the world and made Einstein a superstar overnight. Now you might be thinking, cool, but how does this affect me? Well, your phone's GPS wouldn't work without it. GPS satellites orbit high above Earth where gravity is weaker and time runs slightly faster there. If we didn't account for the space-time time difference, your GPS would be off by kilometers. And now let's go to the extreme case of curved space-time, black holes. These are regions where space-time curves so intensely that nothing, not even light, can escape. It's like a bottomless well in the fabric of the universe. And yes, black holes are real. In 2019, we even took the first photo of one. This photo is the ultimate proof that mass can curve space-time so strongly it traps even light. Let's wrap it up. Space and time form a 4D fabric, space-time. Massive objects curve this fabric. Curved space-time causes what we feel as gravity. Einstein's theory explains things Newton couldn't, like the bending of light and the change in time near massive objects. And yes, it's the reason your GPS actually works. So next time you look at the night sky, remember, you're not just floating in space. You're surfing on a curved fabric of reality. If you enjoyed this journey, smash that like button, subscribe to the channel, and hit the bell icon to keep exploring wrapped reality with Haider.